This is section 3.5. So our problems are 7 through 63 odd. So let me share those with you right now. The 3.5 is on page 329. Starting with problem 7. So we're doing complete factorization now, it looks like. And on page 330. Zeros. So we have complex solutions now, A plus BI stuff. And that should be that. Okay, so 3.5, P of x is x to the fourth plus 4x squared. I don't think I wrote the problem number for that. Problem number 7. So take out the x squared plus 4. So I know this is 0. So x squared plus 4 equals 0. Subtract 4. Take the square root, plus or minus radical negative 4 plus or minus 2i. So the completely factored form, it's fourth degree. That means I should have 4 factors. They are x, x, x plus 2i, and x minus 2i. So the zeros are 0 of multiplicity 2 and plus or minus 2i. Okay, x cubed plus 8. I recall from algebra, I can write it as x cubed plus 2 cubed, which factors in x plus 2, x squared minus 2x plus 4. So I've got x equals negative 2. This one, let's use a quadratic formula. So x is negative b plus or minus the square root of b squared minus 4 times a times c over 2a. That's 4 minus 16 is a negative 12. Take out the i. 12 is 4 times 3. Take out the 2. Cancel the 2. So 1 plus or minus I radical 3. So factored form is x plus 2, x minus each of these. So x minus parentheses 1 minus I radical 3. And x minus parentheses 1 plus I radical 3. So the zeros are negative 2 and 1 plus or minus I radical 3. 21q of x is x squared plus 2x plus 2. It's just a quadratic formula. Negative b plus or minus the square root of b squared minus 4ac. That's 4 minus 8 over 2a. 4 minus 8 is negative 4. Take out the i. Negative 2 plus or minus 2i divided by 2. Negative 1 plus or minus i. So this thing has 2 zeros. They are negative 1 plus or minus i. Factored form, it's x minus each of these. X minus parentheses negative 1 minus I. X minus parentheses, should be a parenthesis there, negative 1 plus I. Okay, x cubed plus x squared plus 9x plus 9. Factored by grouping. Here I can take out an x squared, x plus 1. These two I can take out a 9, x plus 1. Now you pull out the x plus 1, x squared plus 9. So that's going to be negative 1. X squared plus 9, set it equal to 0. Subtract 9, take the square root, plus or minus the square root of negative 9. That's plus or minus 3i. So this factors into 3 terms. Here they are, x plus 1, x minus 3i, x plus 3i. And there's supposed to be 3 zeros. Here they are, negative 1 and plus or minus 3i. Okay, x to the fourth plus 3x squared minus 4. I can think of this as a quadratic in x squared. Factors into x squared plus 4, x squared minus 1. That's easy to check if you multiply this back out. And we know the way this goes. This is going to be x plus 2i, x minus 2i, x plus 1, x minus 1. Right? And by the way, if you multiply this back out, that's x squared minus 4i squared minus 4i squared is plus 4. Okay, so this is the factored form. And the zeros are plus or minus 2i and plus or minus 1. Here we're going the other way, 37. Give a polynomial of degree 2 where the zeros are 1 plus or minus I. So I go x minus 1 minus I, x minus 1 plus I. Distribute x minus 1 plus I, x minus 1 minus I. That's like a plus b, a minus b. So it's x minus 1 squared minus I squared. Minus I squared is plus 1. This foils out x squared minus 2x plus 1. So my final answer is x squared minus 2x plus 2. Okay, degree 3, zeros of 2 and I. Well, if we have real coefficients, complex solutions are always in conjugate pairs. The conjugate of I is negative I. So if I is a solution, so is negative I. And that's the 3 zeros, 2i and negative I. So x minus 2, x plus I, x minus I. That's x squared minus I squared, that's x squared plus 1. multiply this out, x cubed minus 2x squared plus x minus 2. 45. T is degree 4. The zeros are I and 1 plus I and a constant term of 12. Okay, so if I have a 0 of I also have negative I. If I have 1 plus I also have 1 minus I. So the polynomial is some constant times x plus I, x minus parentheses 1 plus I, x minus parentheses 1 minus I. So that's going to be k times x squared minus I squared, x minus 1 minus I, x minus 1 plus I. So this is going to be x squared plus 1. That's x minus 1 squared minus I squared, which is plus 1. And we've already seen that. That's x squared plus 1, x squared minus 2x plus 1 plus 1. The next step is x squared minus 2x plus 2. Okay, I messed up here, but FOIL this out, multiply it out. X to the 4th minus 2x cubed plus 2x squared plus x squared minus 2x plus 2. So that's k times x to the 4th minus 2x cubed plus 3x squared minus 2x plus 2. Now it says the constant term is 12. If the constant is 12, I've got a k times 2. 2 times k is 12. That means k is 6. So make this 6, distribute, and finally here's my polynomial. 6x to the 4th minus 12x cubed plus 18x squared minus 12x plus 12. We said the constant term is going to be a 12. 51, x cubed minus 3x squared plus 3x minus 2. If you plug in 2 works, okay, here it is, plug in 2. Synthetic division, 1, 1, multiply, add, multiply, add, multiply, add, so it works. So I have x minus 2, x squared minus x plus 1, which I can use a quadratic formula for. So x is negative b, 1 plus or minus the square root of b squared, 1 minus 4 times 1 over 2 times 1. That's 1 plus or minus radical negative 3 over 2. So x equals 2 or 1 plus or minus I radical 3 over 2 are my zeros of the function. 55, I got this super long thing here. Okay, 1 works, 1 plus 7 plus 9, that's 18, minus 18 is 0. So I know 1, p of 1 is 0, so x minus 1 is a factor. All right, 1, multiply, add, multiply, add, multiply, add, multiply, add. 0 should be the remainder. Okay, negative 3 happens to also work. It's a factor of negative 18. So 1, multiply, negative 3, 2 minus 3 is 1, multiply, negative 3, add 6, multiply, negative 18, 0. So I have x minus 1, x plus 3, x squared plus x plus 6, quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c over 2a. That's 1 minus 24, negative 23. So the zeros are 1, negative 3, negative 1 plus or minus I radical 23 over 2. There's supposed to be 4 zeros. Here they are. And we could write the 4 factors, but they don't ask for it, so we won't give it to them. Okay, this thing. Okay, 3 happens to work. Okay, so 3, 1, negative 6, 13, negative 24, 36. 1, multiply, add, multiply, add, multiply, add, multiply, add, 0. Okay, turns out 3 works again. 1. 3 times 1 is 3, add 0. 3 times 0 is 0, add 4. 3 times 4 is 12, add 0. So right now my original polynomial is x minus 3 squared times x squared plus 4. Okay, I know that factors into x plus 2i, x minus 2i. So yes, there's supposed to be 4 factors if we allow for multiplicity. X minus 3 squared, x minus 3, x minus 3, x plus 2i, x minus 2i. It's going to give me an x to the 4th and then some other stuff. So here are the zeros. 3 of multiplicity 2, which means 3 and plus or minus 2i. Finally, 5th degree, there should be 5 zeros. 1 works. 1, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, 0 remainder. 1 works again, so just don't have to reinvent the wheel, just start from here. Bring the 1 down. 1 times 1 is 1, add negative 1. 1 times negative 1 is negative 1, add 9. 1 times 9 is 9, add negative 9. 1 times negative 9, negative 9, add them up, you get a 0. Do it one more time. 1, 1, multiply, add, multiply, add, multiply, add. So I have multiplicity 3 of x minus 1, x minus 1 cubed, x squared plus 9. So this polynomial, 5th degree, should have 5 factors. There are x minus 1 cubed, that's like x minus 1, x minus 1, x minus 1, x plus 3i, x minus 3i. So the zeros are 1 of multiplicity 3 and plus or minus 3i. Okay, so these are some problems from section 3.5.